Hello guys, I hope you're doing well. In this video I will be giving an overview of LoRa fundamentals. LoRa is a technology that is used in multiple of the projects that I have offered in the bachelor for the spring of 2023. So the objective of this video is just to give an overview of this technology. So the framework for any given IoT system would include three layers or three planes. It starts with a data collection plane that has a multitude of different types of sensors that collect data for different applications. And you need to send this data wirelessly through given wireless technology, and then the data networking plane will help you network the data or route the data until it reaches the data storage plane, where you'll be doing your cloud computing and your big data processing. So the LoRa technology fits into the interface between the data collection plane and the data networking plane, and it's one of the different alternatives where we're gonna dig a little bit deeper in the next slide. So the typical technologies for data collection in the IoT world have been RFID, Bluetooth Low Energy, 802.15 which is Zigbee, and 802 which is Wi-Fi. And as you can see that this presents a compromise between battery lifetime and between distance. So on the RFID, the battery lifetime is long, maybe it is infinite because the RFID is batteryless, which means that it is only out when it's broken, but it can only cover a certain, maybe less than 10 meters. And then when you go to Bluetooth and Zigbee and Wi-Fi, you can increase the distance of communication, but this is at the expense of the battery lifetime. So as you can see that there is a gap over here where you would like to find a technology that has a long lifetime and long communication distance, and this is where low power wide area networks have evolved maybe 5 years or a little bit longer ago. And LoRa, which we will be discussing in this, the fundamentals of it in the next slide, is one of these technologies. So it supports long battery lifetime, so at the scale of 10 years, and long communication distance at the scale of tens of kilometers. There's actually a third axis, which is the data rate, which is not shown here. But we are not quite interested in it in the LoRa type of applications, because we are supporting applications like smart meters or different applications that are going to send once a minute, once every 10 minutes, once a day, and very short packets. So the access of the data rate in these type of applications are not the most important thing. So the most important thing is the battery lifetime and the communication distance. And this is where these technologies, LoRa and narrowband IoT and Sigfox, but we fit. But we will be discussing LoRa. So just a snapshot of the profile of LoRa in 2021. So the LoRa WAN market has two leaders currently. The first leader is narrowband IoT, and narrowband IoT is the technology that is supported by the cellular industry. And LoRa is the technology that is supported by the unlicensed band. So the difference between them is that cellular technologies use the licensed band, which means that you have to pay a fee in order to be able to communicate over the wireless network. While LoRa uses the unlicensed band, similar, for example, Wi-Fi, you don't have to pay a fee to send on the 2.4 gigahertz band. So the LoRa similarly is unlicensed, which means you can, as an end consumer, you can buy an off-the-shelf component from any store and then just install it and run it without paying a fee to the regulator. And this is one of the reasons why LoRa has enjoyed a huge growth over the last couple of years. You can see that the technology share, so the narrowband IoT is the first currently, followed by the LoRa, and these represent the two halves of the long-range communication world, and the other technologies follow afterwards. The growth rate projected from now until 5 years is around 32%, so there's a huge potential for the growth of these technologies. So just to show you that this picture shows the footprint of LoRa from the LoRa WAN Alliance, and you can see that LoRa has reached or penetrated 141 countries. Actually, the current is maybe this is not the most updated one, but the LoRa has actually reached up to 160 countries. So you can see that the LoRa as a technology has a huge growth potential, and it's very popular nowadays for a lot of IoT applications in smart cities. I will conclude with this slide just to give you an overview of the LoRa fundamentals or the LoRa network architecture. So the LoRa has two components. One component is the LoRa modulation, and I'm not going to discuss this in this video, and then the LoRa network or the LoRa architecture. So you send LoRa signals, which is a patented communication scheme that has the ability to send for long range. And then you have the LoRaWAN specification that defines how will the network be organized. So what we can see, we have three components. We have end nodes. So these end nodes are the applications. These applications have sensors. So you can have an example of pet tracking, a smoke alarm, water meter, trash, gas monitoring, different vending machine, different applications. Now these need to relay their data towards the cloud, which is the network server, and the network server is connected to an application server. In order to do this, they need a gateway, or also called a concentrator. And so the wireless link is between the application and the gateway. And the main difference between LoRa and cellular, where the gateway is equivalent to a base station, is that there is the LoRa or the sensor does not need to register with the base station. It just sends. So if you look at this example of the smart alarm application, you can see that the LoRa device will send its data, and because it's long range, it might be reached or might be received by concentrator number 1 and concentrator number 2, and then it's the concentrator or the gateway has a simple decision to make just to send correct packets through an internet, 3G or 4G or Ethernet, towards the cloud, and all the intelligence of this network is at the network server, and the network server has the responsibility if you receive duplicates. So for example, in this example, you have one packet and one packet from here. These are the same packets. They will go to the network server, which means there will be duplicates, and the network server will be responsible of removing duplicates. And if you want to send back from the network server to the end nodes, it will select which gateway or which concentrator it will send to. So for example, maybe this gateway over here is closer to the smoke alarm than this one. You can know this from the radio signal strength. And then the network server, when it wants to answer back the smoke alarm, it will use this gateway to send the data to the smoke alarm. So this is the architecture of the network, of the LoRa network, where for wireless access, it uses a LoRa, which is a simple random access protocol. So this concludes this video that just gave you an overview of what is LoRa and what is its network architecture. I hope you have been able to grasp the concept, and we will be using, or you can refer back to this video when we discuss about the bachelor topics that are related to LoRa.